Now it's my pleasure to introduce to you Dr. Sidney Carne Wolff from the York High School class of 1958. She is a graduate of Carleton College and U of C, California, Berkeley. She was a professor at the University of Hawaii. She is the first woman to head a major astronomical observatory in the United States. She led the development of 6 major telescope projects, including the LSST, which is the Large Synoptic Survey Telescope. It will survey the entire sky every few nights for 10 years. It will be located on a mountain ridge in Chile, which has been named the Vista Sidney Wolff in recognition of her contributions to the field of astronomy. Please welcome the amazing Dr. Sidney Carne Wolff.
Thank you, and thank you for inviting me back here. I only attended York my junior and senior years, but they really laid the basis for everything that came next. I have not been back here since 1962 because my parents moved away shortly after I graduated from college. I think the good thing about York was it prepared me to have a lot of choices when I got to college, because the preparation here was very broad in science, in learning how to write well, and I learned to love Latin. You mentioned Miss Larson. I remember her very well. I took 3rd and 4th year Latin from her. And in fact, in my sophomore year at Carleton, I had to make the big choice about whether to pursue Latin or astronomy. And the 2 courses met at the same time, and I picked astronomy, and I think that was the right choice, because this truly has been a golden age of astronomy. Now I guess you have to change the slides for me. I remember Carl Sagan saying to me once that this was a magical time to be alive, because in our lifetimes we would visit for the first time every single planet in the solar system. There is one left, and that's Pluto, and the visit will happen in 2015. The spaceship is on its way. All we know about Pluto now is what you see here. This is the best image from the Hubble Space Telescope. There are light and dark patches on Pluto. In 2015, we'll know if it has frozen oceans, mountains, volcanoes, impact craters from asteroids, and we will learn even more about how the planets in our solar system formed. The next slide. Let me see if the laser pointer works. Not that either. Being able to go into space has also advanced astronomy in another way, because we can launch telescopes into space. As you can see from this slide, we can observe now all of the energy that's emitted by astronomical sources, from gamma rays through radio waves. What's shown here, how far the lines go down, the purple lines and the red lines, shows where that type of energy reaches through our atmosphere to the ground. And you can see we can observe radio from the ground, and we can observe some optical and some infrared light from the ground. All the rest is absorbed in the atmosphere. And so we've gotten a new picture of the universe by being able to go into space. But we've also greatly advanced our techniques for doing ground-based astronomy, and in particular we've developed sensors that can detect infrared heat radiation. And the next slide shows a picture of Orion, a constellation you're probably familiar with, and on the left, this is what you would see with your eye in a very dark site. On the right, this is what you would see if you observe in the infrared heat radiation. And what you see are glowing clouds of gas, and those clouds have the raw material, the gas and dust, to form new stars. And star formation is going on in Orion right now, and I have in fact done a lot of work in Orion. My main research field is stellar evolution and the formation of stars and the formation of planets. We now know hundreds of planets around stars other than our own. We haven't found an Earth-like planet yet that can harbor life, but that's because of a limitation of our techniques. We think many such planets do exist. So the next slide. And this is the whole history of the universe in a single picture. And so if you look on the left-hand side, you see the white glow at the extreme left. In the beginning, the universe began its expansion about 13.7 billion years ago, and we're serious about the accuracy of that number. Very rapid phase of expansion. As the universe, it was initially very hot, which is what the white glow shows, and then as it began to expand, it cooled off. You see the green part there. And in fact, there were no stars or galaxies yet. And so thank you for the lead-in to my picture with the Big Bang. The universe cooled off, and for a while it was dark. And so you see the dark stripe labeled the dark ages. But in this universe, there were regions that were somewhat denser than other regions. The denser regions began to collect more and more material, and they began to form stars. And so only about 400 million years after the expansion began, the first stars began to form. And then by about 800 million years, the first galaxies had formed, and we have actually observed those galaxies. Light takes a long time to get from the distant universe to here, so it's a time machine. If we look at nearby stars, the light left them a few years ago. We're seeing them as they were a few years ago. We can actually see galaxies whose light left them over, well, nearly 13 billion years ago. And so it's a time machine, and we can observe this. In the beginning, the galaxies were quite small, but they collided, they merged, they grew, and stars continued to form, and so we have the universe that we see today. So if that's the whole history of the universe, does that mean the problem is solved and there's nothing left for the next generation of scientists? Well, let's look at the next slide. The most shocking discovery, I think, for astronomers in the last 50 years is this one, and that is that we do not know what the universe is made of. You all know about Einstein's equation, E equals mc squared, energy and mass are equivalent. Well, everything in the universe is either in the form of energy or mass. So let's call everything in the universe 100%. Of that 100%, only 4% is made up of the stuff in this room: carbon, nitrogen, oxygen, all the things you're familiar with on Earth and in your body, only 4%. 23% is what we call dark matter. Doesn't emit any light. It exerts a gravitational force, so we know that it's there, but we can't see it, and we don't know what it's made of. And there are laboratory experiments going on right now trying to detect it and understand what it is. Even more shocking, in the last decade or so, we have discovered that 73% of what's in the universe is in the form of what we call dark energy. And that's because we truly don't know what it is. What we've discovered is that the universe is not only expanding, as it expands, it's going faster and faster. Just as in order to accelerate your car and make it go faster, you have to step on the gas and supply energy. Something is supplying energy to cause the expansion of the universe to speed up. Physicists made no predictions about what it was. They have no way to explain it. And so if you don't know what 96% of the universe is made of, I would say there are a few problems left to solve. So the next slide. After graduating from Carleton, my husband, who's here tonight, and I went on to Berkeley. And then after that, we went to the University of Hawaii, which was just beginning to develop astronomy. We now know that the best observing site in the world is on top of Mauna Kea in Hawaii, and this is a picture of Mauna Kea. And when we went there, there were no telescopes on that mountain. And so after spending 17 years there doing this development, we then moved on to the U.S. National Observatory in Tucson, where I was the director. And the next slide shows, in addition to the other telescopes, this is the one that I have been working on most recently, and this was mentioned in the introduction. And this telescope is being designed to help solve the mystery of dark energy and dark matter, trying to understand where the matter is located, how the amount of energy has changed with time, and so on. And so that's why physicists and astronomers are really excited about this telescope. However, if you're going to sell a telescope, and this one is going to cost $600 million to build, it's nice to have a headline story, too, that appeals to Congress. This will find all the potentially dangerous asteroids that might impact the Earth and cause significant damage. And it is the best, cheapest, fastest way to do that. So, the next slide. This telescope has a very large mirror in it. You can see the mirror here with people for scale. And the mirror actually is finished. It was paid for by Bill Gates and Charles Simoni of Microsoft. And then the next slide shows where the telescope will go. You see 2 telescopes already there, and I led the development of those telescopes. The Large Synoptic Survey Telescope will go on the peak on the right of that ridgeline. And this is, in fact, Vista Sidney Wolff. So if you stand where this picture was taken from, this is the vista that you see. And the next slide. This is what the telescope will look like when it's finished in 2022. The money to build this telescope was requested in the budget that Obama submitted to Congress this April. So if Congress would just pass a budget, we could have the groundbreaking in the next 12 months. So again, thank you for inviting me back, and thank you for giving me a chance to say thank you.